and welcome to math class. Today, we are going to be going over 2.3.1. If you would, please make sure to have open a notebook and ready to learn. All right, let's get going today. All right, I'm going to post your homework from 2 days ago on Google Classroom so you can take a look at it so you're not sitting and watching me do that while we're watching this video. So today, lesson 2.3.1, we're going to look at these two learning targets, plotting points on a coordinate graph and looking for a relationship between the two attributes, and then choosing an appropriate scale. So really, this appropriate scale is going to be the main focus of today. So how can I make a graph? How can I make a useful graph? Choosing the graph and a graphing data. Graphs can be useful tools for finding relationships and making predictions. In this lesson, you will work with your team to make choices about how to set up a graph in the most useful way, depending on its purpose. As you work, use the questions below to help focus your discussion. Okay, it's not going to be a discussion since I'm just doing a video, but what I want you to think about is, as you are looking at the data, is does your data fit? Can we see it clearly? Can we make it clearer? And how can we make a prediction? And then lastly, will a different choice make it easier to predict? So today is all going to be about bats, all right? And let me tell you, I did not plan this, but it is really awesome that I'm Batman today and we are doing a lesson on bats. So, all right. Peyton loves bats. She wants to know if she can predict the wingspan of a bat by knowing the length of its body. Peyton looked up measurements for 5 species of bats. For each species, she found a typical bat length from head to tail and the wingspan from tip to tip. She organized the information in the table below. These are all in Tennessee. So you can see the table. Work with your team to decide how Peyton can use the data in the table to predict the wingspan of a bat if she knows its body length. Explain how she would do this. All right, so taking a look, if you would, go ahead and draw this graph on your piece of paper. When you do so, go ahead and restart the video. So hopefully you have a graph now that looks pretty similar to the one that is here. So Peyton has started a graph. Her work is shown at the right. Which axis represents the length of the bat? All right, so the length of the bat, if we go back one slide, notice these values right here are the lengths. All right, notice all of the lengths currently are between 3 and 5 inches. So if we take a look here, the values are currently between the 3 and the 5 inches along the x-axis. And so if we label here along the x-axis, which is our horizontal, this is going to be length. Go ahead and do that on your graph that you've drawn, which means that the y-axis, which is our vertical axis, is the wingspan. All right, length of the wing. So what is the scale of each axis? What that's asking is how many jumps or how many inches does one jump represent? So I see here that this is 5. I'm going to do blue here. And so that's 1, 2, 3, 4, 5. Since it's 5 jumps to 5, it is 1 inch on the x-axis. And then if we look at the y-axis, there's 1, 2, 3, 4, 5 jumps to get to 5 as well. And so it is 1 inch on the x-axis, or sorry, the y-axis as well. All right. Now, Peyton wants her data to be spread out more. All right. Notice everything is kind of really clumped together in the middle of that graph. She wants to spread it out. So I want you to reflect. What kind of changes can you make to make the graph clearer? So, some things that I'm thinking, especially since all of these questions are about the axis and the scale on the axis, the thing that we're going to change is the scale. All right. When you change the scale, which is how much each jump represents, that's going to either spread out or condense the data that is being represented. So taking a look here, this one you do not have to graph. You can just watch as I'm doing it, all right? Peyton's new graph is on the right. How has Peyton changed the scale? Will all of her data fit on the new graph? So I'm going to come back here and take a picture of this real quick. So then we will have that on this new slide. So just so we can graph these points a little nicer, all right? And so we're still putting length down here and the wingspan back or on the left here, all right? And so we've got the big brown bat. The big brown bat is 5. Notice here we've got 1, 2, 3, 4, 5 jumps to get to 10. So our scale now is the length is counting by 2 inches. All right. And so our 2.5 jumps would actually be 5 here. And then we're going up 14. So 2.5, 14 would be about there. Next one is 3.5. Well, here's 2, 4, 3 would be right in between the 2 and the 4, and so it's going to be a little less than halfway between the first jump and the second jump there. All right. Next one is 4.25. So 4 is the second jump, and 1/4 is past there just a bit, and so it would be about like that. All right. The next one is 4.11. That's going to be about right there. And then 3.10. So we're going to make another dot that's about right there. All right. So that's our new graph. If we take a look at this graph and we compare it to what it was here, did our graph get more spread out? I hope your answer is that no, it did not. It's almost indistinguishable. It almost looks like it is a straight up and down line rather than any sort of diagonal relationship, which is what we're expecting on a situation like this. All right. So this is not more useful. Our information is more difficult to read, and the information is too close together. So last question, last 2 questions of the day is going to be, Peyton has come to your team for help, to come to us for help here. We're going to draw this graph on your paper, and I want you to do this right now. I want you to determine, what do you think a good scale would be for the length and the wingspan, all right? You could keep the wingspan or the length at 1. It's up to you, okay? We want to best represent the data and be able to see it really, really well. All right. So go ahead and do that on your own right now, and then come back to the video and we will see what I came up with. So as I was looking at this data here, all right, what I'm noticing is that this data, it has a 0.5, it has a 0.25, and our data really has a small range. And so because of that, what I'm going to do is I'm going to count by a half. It's easy. So essentially each jump is going to be a 1/2 inch. All right. You could go down to 1/4, but I'm not sure if I'd be able to fit everything on there if I went down to 1/4. You know what? I actually think I would, because if I counted by a quarter, that means 4 jumps would be 1, and I'd be able to get up to 5 because this counts by 20. Let's try it. All right. I'm going to zoom in here. So just zoom in just a little bit. Maybe that's a little too far. Okay. So I'm going to count by a quarter. So this would be 0.25, and this would be 0.5. I'm going to start skipping the 0.25 and the 0.75 as I'm counting. So there's 1, there's 1.5, there's 2, there's 2.5, there's 3, 3.5, 4, 4.5, and we get all the way out to 5. So counting by 0.25s here works out pretty well. We can see all of the information that is on there. All right. Most of the information here fits nicely. We're able to see all of them. So I'm going to still count by ones on the left side here. So there's 5, there's 10, there's 15, and there's 20. All right. All right. Now let's do some graphing. So the first one is 514. So I go all the way out to 5 on the length. And up to 14 on, there's 5. I follow it up to 14, which is right there. The next one is 3.5. We go over to 3.5, and we go up to 10. So it's that spot right there. The next one is 4.25, which is going to be the second or the first jump after 4, and we go up to 12. Next one is 411. The last one is 310. Now, one of these pieces of information looks a little bit off. Really, if we would follow the information on the graph, we would assume that it would be about following this nice straight line. But notice how I was able to put every single point on an X point and a Y point. All right. It's not always going to be capable of doing that, but in this case, we were able to do that. All right. So with that information, based on your graph, about what would the wingspan of a bat that is 2.75 inches be? All right. So what I'm going to do is I'm going to draw what is called a line of best fit. And a line of best fit essentially takes the information and it approximates a line that might represent the data. And so what I'm thinking is, if you take a look there, this data looks like it's almost exactly along that line that I just drew. All right. And notice even more, if you take a look at that, notice that it's even going through this 0, 0 point, which is, remember, called the origin. It's going to be one of the most important points for these straight diagonal lines that we're going to see as the year progresses. So keep that in mind as we go. So now we're looking for what would it look like if it was 2.75. So here's our 2.75. I'm going to go up and meet the line right there. And it looks to me like it is just a little bit under, that is 8. All right. And so if a bat has a length of 2.75, we would approximate the wingspan to be about 8 inches. All right. Let's do the same thing for 1. For 1 here, if we follow the 1 up, the 1 looks like it would meet right about at 1, 2, 3. All right. And so 1 inch length is approximately 3 inches in wingspan. And that's that for today. You can look here for some math notes, and those are the math notes on how to multiply mixed numbers. Do make sure that you decide which method is going to work best for you. Is that the rectangular method or using improper fractions? They call them fractions greater than 1, but we can call them improper fractions. All right, tonight's homework / today's homework is on pages 93, 94, and 95. And you're doing 2 115 through 2 120. Now, we are going to test on chapter 2 on Thursday, November 5th. And so when we come back, after this longer weekend, you do not have school on Tuesday. There's no school. We are going to review the chapter 2 material on Wednesday, November 4th. And then we're going to test on Thursday, okay? So please make sure that you are getting caught up with your homework. Thursday, November 5th will be the last time that I accept any Chapter 2 material. So please get caught up if you have not done so. Dark Knight is signing off, and I will see you soon.